It is always a great pleasure for us to welcome a new customer and to see a new airline livery on one of our products. But today, however, is a very special pleasure for us in Airbus industry. Not only because one of our aircraft is in the proud color of British Airways, but also because today sees a major step forward in the long period of courtship between our two companies.
You will know how difficult it is to get one of these fine aeroplanes when you realize that when you remember that we had to buy British Caledonian to get one.
The British Airways Airbus A320, state-of-the-art technology and an aeroplane which has aroused a lot of interest over the past 2 years. My name's Captain John Duncan. I'm Flight Manager Technical, Airbus A320, and I've been involved with the airplane for some 4 years now, the first 2 years leading up to the introduction into service with British Airways exactly 2 years ago. It's an airplane that's aroused a lot of interest amongst pilots worldwide, amongst cabin crew, and most important of all, our passengers. So we on the A320 fleet thought it would be appropriate at the second anniversary to show you some of the more advanced features of the aeroplane and why we are so enthusiastic for it. So let's have a look.
5 years of work by Europe's major aircraft manufacturers were needed to perfect the aircraft, the first to be equipped with digital fly-by-wire computer systems. Before it can reach its scheduled production level of 8 aircraft per month in the final assembly hall at Aerospatiale Toulouse, a complete production system had to be put into place. 4 major partners cooperate to make the program a reality. MBB in West Germany is responsible for building fuselage sections and furnishing the completed aircraft. CASA in Spain builds the horizontal stabilizer, an all-composite structure, another first in aircraft construction, as well as fuselage panels and passenger doors. British Aerospace designs and builds the most advanced subsonic wings in the world, and Aerospatiale of France designs and builds the flight control systems, the flight deck and the forward fuselage, and is responsible for final assembly. One of the keys to the success of the most advanced production system in the world is the Skylink, a sort of flying whale whose enormous belly swallows the wings or the fuselage of an A320, transporting them from distant factories to final assembly line at Toulouse, saving time and saving money for maximum efficiency. No more than 48 hours elapse between work finishing on a sub-assembly and work starting on it again hundreds of miles away, as it begins the next step in its journey to become part of a complete aircraft. 4 Skylinks keep up the flow of sub-assemblies of Airbus products between the partners, and finally they all come together on the assembly and integration lines at Aerospatiale Toulouse. 25,000 people in 5 countries, a level of true cooperation never before achieved in Europe, enabled the first A320 to roll out of the final assembly hall barely 30 months after manufacture of its smallest elements began. At 8 a.m. on the 22nd of February 1987, Chief Test Pilot Pierre Baud and his 4-man flight test crew took their places aboard the new airliner. The first flight was scheduled to last 3 hours. In fact, the crew was able to sample the complete operating envelope of the aircraft, high and low speed, high and low altitude, in a completely successful 4-hour flight. A very promising start to a very demanding flight test program.
The flight was superb, but our first thoughts go to all those who for years have put their hearts into building such a fantastic aircraft.
The first flight was a milestone marking the start of a long road to a tight schedule of testing. Testing also continues on the ground, the effects of bird impact at high speed on the flight deck and the wing. The landing gear is subjected to stresses far higher than it will ever receive in service. The whole airframe is tested rigorously and mercilessly. The engineers verify how the aircraft will age under its operating conditions and its behavior in unfavorable climates. At this stage of testing, the skilled application of computer power increases the thoroughness of the testing process and cuts down the time to produce the required results. Data from sensors throughout the aircraft are transmitted to the Flight Test Control Center for immediate analysis by engineers on the ground, as well as the flight test crew. The screen in the control center shows all the flight parameters in real time. To ensure that flooded runways will have no major effects on the engines and the air conditioning system, a special and spectacular test is required. At Luleå, in northern Sweden, well within the Arctic Circle, the A320 stands outside all night, with an outside temperature of more than 20 degrees centigrade below freezing. No problems on startup the following day, nor during the subsequent test flight. Performance testing also includes determining the minimum speed at which the A320 will unstick from the runway, VMU. The pilots themselves are tested. Heart rate sensors enable doctors to determine stress levels on the flight crews as they cope with problems which could occur during flight under the watchful eyes of the certification authorities. The tests prove that the A320's advanced technology enables the flight crew to perform their tasks of command and control more efficiently. All the data are recorded for computer analysis. After every flight, a hot debrief enables the crew's immediate reactions to be noted. After every day's flying, some 7 flights per day in this intensive operational test, a general debriefing covers all the points that have come to light and sets the tone for the test sequences still to be flown. The final testing stage involves the participation of its future operators, and the context is once again the real world of airline operation. The A320 is flown in the actual conditions it will soon encounter once in service under airline colours serving 20 destinations across Europe: Paris, London, Frankfurt, Stockholm, Athens, Hamburg, as well as Marrakesh and Tunis. From the winter cold of Scandinavia to the warmth of North Africa, the A320 proves that it fits into its destined operating environment as it was designed to. 15 years ago, flight testing and certifying the A300 took some 16 to 18 months. The new technology, applied to flight testing the revolutionary A320, and particularly the real-time analysis of telemetered test data, enabled this ambitious program to be successfully concluded in less than a year. And on the 26th of February 1988, another first. For the first time, the authorities of 4 countries, West Germany, France, Great Britain and Holland, jointly signed the certificates of airworthiness of the A320.
So here we are on the flight deck of the A320, the front of an aeroplane that from the outside looks pretty conventional, but of course we've got the highly efficient wing built by British Aerospace, two very fuel efficient engines built by the consortium of GE and SNECMA, CFMI. Very comfortable, spacious cabin, and here at the front, the flight deck. The first obvious difference is the lack of the old-fashioned control column, which is replaced by the very nice to use side stick, which requires less physical effort and from a pilot's point of view is very nice to use. As you'll see later on in the simulator, pilots adapt very rapidly indeed. In fact, after the first 15 minutes in the simulator, they feel quite at home with the side stick. The next obvious difference is the two screens in front of each pilot, on which a tremendous amount of information is displayed. And these replace up to 40 of the old conventional analog type instruments, of which we've got a couple for standby purposes only. And in the center of the airplane, between the pilots, we have the electronic centralized aircraft monitor, which gives both pilots all the information that they require about systems and their operation on the airplane, and in the event of an abnormal or emergency situation, also give the pilots the drill to carry out, and the lines of the drill do not disappear from the screen until that action has been carried out. Again, a tremendous amount of information is available to the pilots for each system. Just below ECAM we have the flight management and guidance system, a fully integrated flight management and guidance system coupled with the auto-flight system that gives us optimum flight paths, and in poor weather it gives us an all-weather landing capability second to none. The A320 is currently cleared for Category 3B operations, which means here at London we are landing in 75 meters visibility with no decision height, a capability that only a few other airplanes possess at the moment and a significant number of other airplanes do not. And this of course gives us a key advantage in the weather that we sometimes experience not only just at London but in Northern Europe. Also on the right-hand MCDU we have the centralized fault data system, which when coupled with ACARS next year will automatically downlink a tremendous amount of information for engineering. It will also have the facility with ACARS to uplink weather and company messages to the pilots, but it records in real time minor defects that may occur to the airplane. At present we have the facility to do a post-flight print, which is done automatically, but we can demonstrate it here simply by pressing the lower right line select key, and the post-flight report appears. About 83% of the systems on the airplane have built-in test equipment, all coupled to the centralized fault display system, the centralized fault data system, which next year will be automatically downlinked via ACARS to engineering. At present, the post-flight print is supplied automatically at the end of each flight, and this information is passed on to engineering, who assess it and see if any maintenance action may be required either in the short term or in the long term. The object of the exercise with ACARS is to monitor engine and APU health in real time to avoid unscheduled engine changes away from base, which can be expensive and costly in terms of downtime with the aeroplane. Behind the flight management computers we have the throttle system, which is connected to the engines by the full authority digital engine control system, and again does a lot for the pilot. FADEC looks after engine starting, making sure that no temperatures or pressures are exceeded in the engine, carries out fully automatic starts, up to 3 of them, without any intervention required by the pilot. Coupled to the auto flight system, it makes for a very stable trajectory. It keeps the workload down to a minimum, and whether the airplane is being flown automatically or manually, certainly a feature that is very much appreciated by the pilots. Overall, we have a spacious flight deck, much wider and much more room than some of the older technology airplanes. For example, the 111 that I've come off, after the 111, this is extremely spacious and a very nice office environment. So, having had a brief conducted tour of the flight deck, we're now going to have a look at it in action, and to do that we're going to join Captain Martin Hull, Flight Training Manager on the A320, and we're going to look at one of the simulator details that he's conducting.
This is the A320 simulator. We use this for all our pilot training, both conversion onto the aircraft and also for the recurrent training which we do every 6 months. It's made by rediffusion. It does have computer control from a separate room at the back, and there's a certain interaction between the computers on board the aircraft and the computers in the room. Quite a complex process. It's got a 6-axis motion to make it much more realistic as far as training is concerned, and it also has a wide-angle visual system.
Speedbird 461, the maintain heading 210, you're clear ILS, call established.
Right, continue heading 210, call you established, runway 25, Speedbird 461.
Cheers, Squad Blue, Cat 3.
Confirmed.
Cat 3, Joe. Okay, yeah, take flap 1.
Speed checks, flap 1. Clear the status.
Please.
Flat 1 set. Speedbird 461, localised, they're established, runway 25.
461, call tower 118.1.
1181, Speedbird 461. Tower, good evening, Speedbird 461.
Speedbird 461, good evening, call passing the Markham.
Speedbird 461, roger.
Okay, 4,000 to go around, please.
4,000 is set.
Flap 2, please.
Speed checks, flap 2.
Gear down, landing checks.
Speed checks, flap 2 is set. Gear down. Cabin crew, take your seats for landing.
Flap 3.
Speed checks, flap 3. Cabin signs are on, gear is down. Greens, rails checked. Spoilers are armed. Cabin crew are warned. Flap 3 is set.
Full flap, please.
Speed checks, flap 4. Flap 4 we have. Your flap to check.
Full flap confirmed.
So landing check is complete.
Yeah.
Speedbird 461, out to mark 25.
Speedbird 461, you're clear to land the runway 25, the wind 220, 15 knots.
Clear to land 25, Speedbird 461.
1,000 radio.
Okay, man land 220 Barrow, I have control.
You have control.
Autopilot coming out.
Okay. feet above.
200.
Descend.
Land.
One 100. 60. 30. 20. Retard. Retard.
Reverse you have. Seventy knots. First side. Forward island.
Speedbird 461, next right and call ground 1219.
Next right and the 1219, speedbird 461.
Right, good. We'll set you back on the end of the runway then. You've finished all those checks, haven't you? I don't think we need anything else. We'll do another takeoff.
Flex SRS runway. Power set. 80 knots.
Stop.
$70 knots.
Okay, you have control.
I have control. Carry out the cam control, please.
Thrust levers going to idle. The aircraft is stopped. Parking brake is going on.
Barcelona, speedbird 461. We have an engine fire stopped on the runway.
Engine master 1 going
service
off.
meters, please.
Fire service is on the way.
Thank you.
Agents are discharging. ATC you've notified.
Cabin crew, we have an engine fire on left-hand side. Stand by to evacuate.
Okay, still got an engine fire. Engine master 2 going off. And into the Jaws.
Okay, I think you can leave it at that. We'll set you back on the end of the runway then. If you call for your clearance, I'll give it to you. Okay, you ready, Phil?
Madrid, speedbird 461 is ready for departure.
Speedbird 461, you're clear for takeoff. The wind 2405 knots.
Clear takeoff, speedbird 461. Okay, below the line then. Cabin crew, take your seats for takeoff. Flags are both on. Jets complete. Flex SRS runway. Power set. $80 knots. Rotate. Positive climb.
You're up.
Speedbird 461, climbing straight ahead to 8,000 feet.